Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to complete section 6.5 by looking at a process called the rational root theorem. Now, remember what we have been doing with 6.5. We have been finding the zeros or the roots of polynomial functions. At the beginning, everything was factorable. So you were able to factor the polynomial, then you set each piece separately equal to 0 and solved. Then we ran into a little road bump where we could not factor everything. So what we did, we went ahead and graphed on a graphing utility called Desmos.com to see where the graph touched or crossed the x-axis. Then we could proceed using synthetic division. Well, today, our problem is we don't have a graphing utility, okay? Let's say your iPad died, your Chromebook isn't working, the internet is down. What do? That's where the rational root theorem can help us. Okay, so we can go ahead and find possible solutions without looking at a graphing utility. I often call this process the PQ method because what you use are values that they indicate as P and Q. P is your constant. It is the number at the end of the problem that does not have a variable. Q is your leading coefficient, the number out front. Then, if you can list out the factors of each, you get like a table of possible solutions, and you just do trial and error until you find a solution. So let's go ahead and look at this. If I have x cubed minus 7x squared plus 14x minus 6, right away I know that I need to find 3 solutions to this problem because my degree is a 3. There are 4 terms, so if I look and see if I can group, I could take out 2 x's, that would give me x minus 7. Yeah, that ain't working. Well, that would be x minus 7. I can't make that x minus 7. We can't go to Desmos because the internet is down. So what you have to do is go P over Q. P is the constant at the end, so it's a negative 6. Q is the leading coefficient. It's an unwritten 1. Now, you don't divide these. You're not saying negative 6 over 1 is negative 6. We are listing the factors. What can I divide negative 6 by and not get a decimal? Well, you could divide by a positive or a negative 1. 6 would be divisible by a positive or a negative 2. You could divide negative 6 by positive or negative 3 and not get a decimal. You could divide by positive or negative 6. Over. What can you divide 1 by and not get a decimal? Positive or negative 1. So your possible solutions, I have to take all of the values on the top over the values on the bottom. So 1 over 1 is 1. So positive or negative 1 could be an answer. 2 over 1 plus or minus 2 could be an answer. 3 over 1 positive or negative 3 could be an answer. 6 over 1 plus or minus 6. So here is a list of your possible rational solutions. Now, you could have imaginary solutions or irrational solutions, meaning you have square roots, but your rational solutions have to come from this option or this list right here. So now what we have to do is start doing synthetic division until we find one that works. To save you time, we look at synthetic division as a table. So P over Q goes in the corner because we're taking from our list we just created from our rational root theorem. Now it is synthetic division. So across the top, I have 3 x's, 2 x's, 1 x's, no x's. I do not have to add in any zeros. There is 1 in front of x cubed, negative 7 in front of x squared, 14 in front of x, negative 6 at the end. Now, you guys, we just start trying numbers. So if I try a 1, because 1 is a possible solution, this is synthetic division. So you carry down the first term. This is like the number in the box. So you multiply. 1 times 1 is 1. Add. 1 plus negative 7 is negative 6. Multiply. Negative 6 times 1 is negative 6. Add. Negative 6 plus 14 is 8. Multiply. 8 times 1 is 8. 8 plus a negative 6 is 2. So nope. It does not touch at 1. Well, maybe it'll touch at negative 1. We know that it's a solution. Remember, if that's a 0, that was not a 0. That's how I know it's not a solution. Carry down the first term, that's a 1. 1 times negative 1 is negative 1. Add. Negative 1 plus negative 7 is negative 8. Multiply. Negative 8 times negative 1 is positive 8. 8 plus 14 is 22. 22 times negative 1 is negative 22. Negative 22 plus a negative 6 is a negative 28. So nope, negative 1 is also not a solution. Now I will tell you there is no shortcut. Like I can't look at that and there's no trick to be able to determine where I'll find a remainder that's 0, so you just keep trying. So I know positive 1, negative 1, those are not solutions. So let's move over to 2. Carry down the first number, that's a 1. 1 times 2 is 2. Add. 2 plus negative 7 is negative 5. Multiply. Negative 5 times 2 is negative 10. Add. Negative 10 plus 14 is 4. Multiply. 4 times 2 is 8. Darn it. 8 plus a negative 6 is 2. Doesn't work. So now let's go ahead and try negative 2. It's just trial and error, okay? Let's go ahead and drop down the first term. It's a 1. 1 times negative 2 is negative 2. Negative 2 plus negative 7 is negative 9. Negative 9 times negative 2 is positive 18. 18, holy smokes. Yeah, this is getting kind of yucky. Okay, negative 9 times negative 2 is 18. If I take 18 plus 14, you guys, I'm getting 32. So 32 times negative 2, well, that's negative 64. Negative 64 plus a negative 6, that's negative 70. So nope, it did not work for positive or negative 2. So guess what? We just keep on going. Let's go ahead and move to the 3s. We got to find an answer at some point here. Okay, so if I drop down the first term, that's a 1. 1 times 3 is 3. 3 plus a negative 7 is negative 4. Negative 4 times 3 is negative 12. Negative 12 plus 14 is 2. 2 times 3 is 6. Oh, goodness gracious. Good job. 6 and a negative 6, that's 0. When you get a 0, that means that you found a solution. So we know that whatever number was in the box, that's an answer because the remainder is a 0. So x equals 3. Yes, we have an answer, but we need 3 answers. So this is a remainder. You don't do anything with it. This is a solution. We said already that x equals 3. Next to your remainder is a number. Next to your number has an x. After that, you have x squared. So I have 1x squared minus 4x plus 2. At this point, it's quadratic, meaning you have a power of 2. You have 2 options. You can factor it if there are 2 numbers that multiply to 2 and the same 2 numbers add to negative 4. Here, we can't do that. There are no 2 numbers that multiply to 2 and add to negative 4. So your other option is the quadratic formula. Quadratic formula. The number in front of x squared, that's a. B, the number in front of x. C, the number at the end. Start off by figuring out what number goes underneath the radical. It's b squared minus 4 times a times c. If I go ahead and I calculate that, negative 4 squared minus 4 times 1 times 2, I get 8. 8 is not a perfect square root, so I have to see if I can break it down. 8 would end up being 2 square roots of 2. So let's look at this. X equals negative b. B is a negative 4, so it's a positive 4. Plus or minus, if you have 8 underneath a square root, it simplifies to 2 square roots of 2 all over 2a. A is a 1. 2 times 1 is 2. Anything that is not underneath the radical, you have to simplify if you can. So here are my other 2 solutions. 4 over 2 is 2. Plus or minus, the 2's cancel, square root of 2. So this is actually 2 answers. 2 plus a square root of 2, 2 minus a square root of 2. Those are your 3 answers. That's how we can do this without a graphing calculator. Yes, it is quite the process, but it's kind of cool to be able to do this by hand. Let's keep on going. We're going to do at least 3 more examples together, okay? So step 1, you try to factor it if you can. If I go ahead and group those 2, I could take out 2 x's and I'd have x plus 10. That cannot be x plus 10, so we cannot factor this. You can't go to Desmos because that's not an option today. So you take p over q. P is the number at the end, so negative 28. Q is the number at the beginning, it's a 1. Now what you do is you list out the factors. I can divide 28 by positive or negative 1. 28 is divisible by 2, not by 3. 28 I can divide by 4, not 5, not 6. 28 is divisible by 7. Now here's a little trick. If you get two numbers that are next to each other and they multiply to the number that you started with, everything will have a partner. So 4 times 7 is 28. So your next factor partners with 2. 2 times what is 28? Well, that's 14. The next partner will go with 1. 1 times what number is 28? That's 28. All over 1, which is plus or minus 1. Now, when the denominator is just a 1, your possible solutions are whatever the remainder is. Because the top divided by 1, everything would be the same. 1 divided by 1 is 1. 2 divided by 1 is 1. 4 divided by 1 is 4. Okay, 7 divided by 1 is 7. So when the bottom is just plus or minus 1, it will always be whatever is on the top. Okay, let's keep on going. So now let's go ahead and start trying to find our zeros. So remember, this is synthetic division. So I have a 1 in front of x cubed, 10 in front of x squared, 17 in front of x, negative 28. Now you just go ahead and try numbers. If I put a 1 here, this is synthetic division. Carry down the 1. 1 times 1 is 1. 10 plus 1 is 11. 11 times 1 is 11. 11 plus 17 is 28. 28 times 1 is 28. 28 plus a negative 28 is 0. Okay, this is awesome because I found my 0 right away. X equals 1. That is a solution. However, I need 3 solutions because that's what the degree is. This is a remainder. You don't do anything with it. 1 is a solution. So what I have are the numbers in between. This is a number. This is x. This is x squared. So now I have x squared plus 11x plus 28. I can factor this. Two numbers that multiply to 28 and the same two numbers add to 11, that's 7 and 4. So this would be x plus 7, x plus 4. In order to find zeros by factoring, you take each group separately and you set it equal to 0. So if I minus 7, 0 minus 7 is negative 7. There's a solution. If I minus a 4, 0 minus 4 is negative 4. I have 1, 2, 3 solutions. We are done, and we did not need graphing technology. Okay, let's look at another one. This time, we have a number in front of our first term. Our leading coefficient is not a 1. So P over Q, well, first let's see if we could factor it. I could take out x squared. That would leave me with 3x plus 10. I can't make that 3x plus 10. P is the number at the end. It's negative 10. Q is the leading coefficient. You list out the factors. 10 can be divided by 1, by 2, by 5, and by 10. Those are all the factors of negative 10. 3 can be divided by 1 and 3. Now, here's how you find that list if there's more than just a 1 on the bottom. All of the numbers on the top have to go over 1 first. 1 over 1 is 1. 2 over 1 is 2. 5 over 1 is 5. 10 over 1 is 10. So now I'm done with the 1. Now, all of the numbers on the top have to go over 3. 1 over 3 is 1/3. 2 over 3 is 2/3. 5 over 3 is 5/3. 10 over 3 is 10/3. So my possible solutions that I can try using synthetic division all have to come from this list. Let's go ahead and get started and try to find some solutions. Okay, that marker's starting to die. Here we go. Remember, this is synthetic division. 3x's, 2x's, 1x's, no x's. I don't have to add in any zeros. My numbers on the top, I have a 3, I have a positive 10, I have a negative 27, and a negative 10. You can start anywhere. These are your possible answers. If you really like fractions and you want to start with fractions, you go for it. I typically like to just start with positive 1, negative 1, and I just kind of work my way through. Sometimes it kicks me in the butt because let's just say that the first answer that would work is negative 2/3. I would have tried all of these values, okay? So there is no rule that says where you start. You can start trial and error. Your answers have to be from within this list, okay? Again, I like to just start off with 1 because they calculate quick, and like the last one, when I tried 1, it worked. So look how quick that problem worked, okay? Let's drop down the first term. It's a 3. 3 times 1 is 3. 3 plus 10 is 13. 13 times 1 is 13. 13 plus a negative 27 is negative 14. Negative 14 times 1 is a negative 14. That doesn't work. Darn it. Let's try a negative 1. Carry down the first term. That's a 3. 3 times negative 1 is negative 3. Negative 3 plus 10 is 7. 7 times negative 1, well, that's negative 7. Negative 7 plus a negative 27 is negative 34. Negative 34 times negative 1 is positive 34. 34 and a negative 10 is positive 24. Nope, it's not a positive or a negative 1. So now we move on. Let's see if we can get it to work with a 2. Carry down the 3. 3 times 2 is 6. 6 plus 10 is 16. 16 plus 2 is 32. 32, oh good, this is going to work. 32 plus a negative 27 is 5. 5 times 2 is 10. Positive 10, negative 10 is 0. You will be surprised how excited you get when you get remainders of 0 when you start doing this process. X is a 2, so I have one answer. I need 3 solutions. So I have 1/3 of my answers. This is my remainder. This is my solution. So what I have, this is a number, this is x squared. I have 3x squared plus 16x plus 5. I could do the quadratic formula, or I can factor this, okay? So I'm going to go ahead and factor just to remind you what you do if there's a number in front of the squared term. I take the first term times the last term. So 3 times 5 is 15. I need 2 numbers that multiply to 15. The same 2 numbers add to 16. Well, you guys, that's 1 and 15, because 1 times 15 is 15. 1 plus 15 is 16. Because there is a number in the front, I am taking these 2 terms and you replace the middle. The first term stays, the last term stays. The middle term had an x. So when I fill in my positive 1 and positive 15, they too need to contain an x. So what I did here is basically I uncombined my like terms. If I had this and I combined my like terms, 1x and 15x would make my 16x. Now I have 4 terms, so grouping will work. If I look at these 2 terms, I could take out an x. That would leave me with 3x plus 1. This needs to become 3x plus 1. I can do that. If I divide out a 5, I would have 3x plus 1. If this matches this, you know you did this correct. Whatever you took out, that becomes one group. What they have in common, that is your other group. Now I take each group separately, set it equal to 0, and I solve. So here you would minus 5. 0 minus 5 is negative 5. And check this out. Negative 5 was one of my possible answers. Here I would minus 1 divide by 3. So if I minus 1 would be negative, negative 1/3. Negative 1/3 was an answer. So had I selected negative 5 or negative 1/3, that's where I would have gotten my other remainders that were a 0. I needed 3 solutions. I have 2, negative 5, negative 1/3. We are done. Let's do one more. Okay, so again, I have 4 terms that we can't factor. I could take 2 x's out and I would have 2x minus 3. I can't make that 2x minus 3. I do not have graphing technology with me, so we're using what's called the rational root theorem. P is your constant at the end. Q is your leading coefficient. So my numbers that I'm using are 6/2. 6, I can divide 6 by positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6. 2 is divisible by 1 and by 2. So now to find the solutions, your list, all of the numbers on the top go over 1, then all of the numbers on the top go over 2. So 1/1 is 1, 2/1 is 2, 3/1 is 3, 6/1 is 6. So I'm done with the 1. Now I take all the numbers on the top over 2. 1/2 is 1/2. 2 over 2 is 1. That's already stated, so you don't have to state that again. 3 over 2 is 3 halves. 6 over 2 is 3. So here is your complete list. Now I go ahead and start off with synthetic division in our synthetic substitution table is what this is called. 3x's, 2x's, 1x's, no x's. So I don't have to add in any zeros. The numbers that I'll use are 2, -3, -11, and +6. Now we just start trying those numbers. If I start off with a 1, carry down the first term, 2 times 1 is 2. 2 plus a -3 is -1. -1 times +1 is -1. -1 plus a -11 is -12. -12 times 1 is -12. -12 plus 6 is -6. So nope, it does not touch or cross at 1. Let's try -1. Carry down the 2. 2 times -1 is -2. -2 plus -3 is -5. -5 times -1 is +5. +5 times a -1 is -6. Darn it, I got excited. I thought this was going to work. -6 times -1 is a +6. 6 plus 6 is 12. So that did not work. Let's look at a 2. Carry down the 2. 2 times 2 is 4. 4 plus a -3, well, that's 1. 1 times 2, that's 2. 2 plus a -11, well, that's -9. -9 times 2, that's a -18. -18 plus 6, -12, nope, doesn't work. Let's see if -2 works. Carry down the first term, that's a 2. 2 times -2 is -4. -4 and -3, when you add them together, you get -7. -7 times -2. Negative times a negative is positive, so this is +14. +14 with a -11 is 3. 3 times -2 is -6. Yes, 6 and a -6 is 0. So we have one answer. X equals -2. I need 3 answers, okay? But this is usually the hardest part, is going ahead and finding that first solution. This is a remainder. We don't do anything to that. This is a number, this is x, this is x squared. So I have 2x squared minus 7x plus 3. I could do the quadratic, or again, I can factor this. Just to practice that factoring technique, let's go ahead and do that. Multiply, add. 2 times 3 is 6. I can add to -7. So two numbers that multiply to +6 but add to -7, that's -1 and -6. Negative times a negative gets me a positive. 1 times 6 gets me 6. If it's -1 degree outside and it drops 6 more, you're at -7. Because of the number in the front, these two terms replace the middle. 2x squared minus 1x minus 6x plus 3. So again, notice the first term and the last term stayed. The middle became two terms that if I combine like terms, I get back to the original. Now that I have 4 terms, my grouping method does work. If I look at these two terms, I can take out an x. So that would be 2x minus 1. I can make this 2x minus 1. If I have -6x and I want a positive 2x, I need to divide out a -3. Well, if I divide both of these by -3, I get that 2x minus 1. What I was able to take out, that forms one group. What they have in common, that's another group. Now, to use factors to find solutions, you need to take each piece separately and you set it equal to 0, so that way you can solve. Here I would add 3. 0 plus 3 is 3. Here I would add 1, so it would be a positive 1 divided by 2, so x equals 1/2. I need 3 solutions. I have x equals -2, x equals 3, x equals 1/2. So we know, without using graphing technology, where this polynomial would cross the x-axis. All of these have a multiplicity of 1, so as it crosses all 3 locations, it would cross as a straight line. Your assignment today is a worksheet where you are going to try 3 of these on your own. I hope you enjoyed learning a new concept today, and I'll talk to you soon.